we have to digress and get this whole thing of linear equations down because people are not getting correct solutions. Okay, at least not consistently. Some people are, most people aren't. Okay, so what do we do here? Well, I think everybody is okay with the distributive law. We just multiply 2 by 3x to get 6x, and then 2 times minus 5, which is minus 10, right? And now that's equal to 4x plus 2. And I think everybody got that step. Okay, so that's a good start. At this point, remember, we've used the distributive law. We don't really need it anymore, although sometimes we would need it in a couple of steps. We want to isolate x. Okay, we want to get x all by itself on one side. Now we can just write down x equals and hope that what we write on the other side is correct, but that's very likely that it would be. Okay, we can't just do that. We have to keep the equation in balance by adding or subtracting from the same thing on both sides and multiplying or dividing both sides by the same thing. And if you multiply a side, you got to multiply the whole side. You can't just like multiply this by a number and this by a number and not multiply these by the same number. You multiply the whole side. So the way you do that, well, we're not going to do that just yet because the problem we have is we're trying to isolate x. We got an x on this side, we got an x on this side. What are we going to do about that? Well, I think if we subtract 4x from both sides, then it'll disappear from this side and reappear on this side, etc. Okay? So the way people often want to do that is they want to do minus 4x here and minus 4x here. I've seen a lot of errors in a couple of classes where people do this and they don't do it right. Okay, I really don't want to see this unless I also see this. What this means is, and also I want the equal sign there because I've seen people, I'm not sure in this class, but it could be, I've seen people write a 4x here and a 4x here and then put them both on the same side. They don't have the equal sign, so it doesn't line up, so they just do what it looks like. Okay? I don't think anybody in here did that. But it's something that can be done. So we put the equal sign there to keep things aligned. Is that clear? We always put an equal sign if we do this. And then the other thing we're always going to do, unless you can prove to me that you can solve linear equations correctly and efficiently by whatever method you're using. Okay, and somebody probably can. I want you to write down, I don't want you to do anything with these numbers. I want you to write down 6x minus 10 minus 4x equals 4x plus 2 minus 4x. Meaning that we write down this expression here and this expression here automatically. We write these two expressions down, and then we write minus 4x minus 4x. Okay? Because this is what you're doing. You're subtracting 4x from both sides. And if you have it in this form, you're less likely to do some of the things that I've seen when you write it like this. Okay? So if you're going to do this, then that's all right. It's valid. You just add these two and you get this. Then you simplify it. Okay? So what are we going to get? Well, we've got a 6x and a minus 4x. What's that give us? 6x and minus 4x. How many x's? 2 x's, right? So we got 2x minus 10. And the 4x doesn't have to be right next to the 6x. We can, in our mind, rearrange this thing. We put that 4x, negative 4x anywhere we want to, right? But I put it here because I want you to write down this side before you put the minus 4x there. And I want you to write down this side before you put the minus 4x there. After you've solved 100 of these, you can start taking shortcuts. That's advice. I can't control what you do when you do your homework. Okay? And take a test and do it wrong. I'm not all that sympathetic if you're not doing it in a valid way. Okay? So this is the way you assure that it's valid. Okay, so you got then 4x. Well, sorry. How many x's you got on this side? You don't have any. You got 4x minus 4x. You're subtracting a quantity from itself. Get 0. So it's 0 plus 2. I'll put the 0 there just to emphasize that 4x minus 4x is 0. You know that. Okay, then I'm going to write this once more. There's no, I'm not going to get through it. 2x minus 10 equals 2. Now, what people are going to want to do is they're going to want to put a plus 10 here. And a plus 10 here with an aligned equal sign. I've seen people get in all kinds of trouble by not aligning their equal signs. And I'm not usually all that careful about it because I assume people can solve these equations. But since I'm seeing so many errors across 3 of my classes, okay, I'm going to be real careful about that. Okay, now, you know, some people will do if they see this step, they'll add that 10 to that 2. I've seen a lot of that. Okay, or they'll multiply the 10 by 2 and get 20x. This tells me that we need to be clear about what we're doing in each step. Okay? You're not going to do that if you do what I say. And what do I say? I say you take this and write it down. Here's your 2x minus 10. Take this and write it down. Here's your 2. This equation is still true, provided these steps were right. And then we put the plus 10 on it. Now, why don't you add that 10 to that 2? It's because these are unlike terms. You don't know what x is. So if you add 10 to 2, you get 12x. Okay? But 12x means something different. If x is 3, 12x is 36. If x is 9, 12x is 108. 12x is variable. You can't add a constant term to something that's variable. 10 is constant. Well, anyhow, now, since you got the negative 10 plus 10, you're going to see it immediately. You're going to see that that's going to just leave you 2x. I won't bother writing the 0, but 2x equals 12. And now what do? We divide both sides by 2. I'd really prefer that you not draw lines through these things because people don't understand the rules for cancellation. Most people don't. Okay? Now, if I don't see you making any mistakes in cancellation, it's okay, go ahead and cancel. But as soon as I see you making mistakes, I'm going to tell you, don't do that anymore. Do what I'm telling you to do. What's 2x divided by 2? Well, the 2 divides the 2, doesn't it? 2 divided by 2 is 1. That just leaves you x. Now you put a slash through it. Well, that's legal cancellation. The reason is 2 is a factor of the numerator. I explained this in the video that I kind of want you to watch. Okay? That means 2 is multiplied by the whole rest of the numerator. Okay? That's what a factor is. You can cancel factors. You cancel a factor of the numerator with a factor of the denominator because since everything is multiplied by, this is multiplied by the numerator and this is the denominator, you can isolate it and divide it. Okay? If it was 2 plus x, you wouldn't be able to do that because if you have 2 plus x, 2 is not multiplied by the rest of the numerator. You have a plus x. There's no multiplication involved. I'll do an example of that. Anyhow, so x equals 6. And if you get 6 and plug it back in, you're going to get 26 equals 26. Isn't that right? Let's see. Yeah. Okay. Now, when you solve these, I want you to write out the check. That'll tell you right away whether you did it right or wrong. Of course, you mess up the arithmetic in the check, which is possible. Then you get misled a little bit. Well, it's a game. Okay. You're trying to reconcile it and get it right. So if your check doesn't work, either you made a mistake in your check or you made a mistake in your original problem. Okay. You got to figure out which, and then figure out where the mistake was. A lot of common errors. I mentioned several of them. You know, doing this without taking this step, doing this without taking this step, not putting an equal in this. Those are the common errors that I've seen all over the place. And then adding unlike terms. Doing this without writing this out leads to a lot of confusion where you add things that you don't mean to add, and sometimes even multiply by things that are supposed to be added. There's an epidemic. But this is something you did right when you took Algebra 1. Okay? You just need to be clear on the rules, and I've moved the assignment on linear equations up to where you have to do that. Okay? And that should give you a review, and you should do just fine. I don't suspect anybody in here, the pattern of your work is too clear, and you know what you do in class is consistent with what they did for homework. But a lot of times I see perfect solutions to linear equations up and down. I said, boy, people really know these. They're getting those off the internet, showing all the steps off the internet, not learning a thing. So they come to a test and can't do it. Now, you all aren't doing that. But the point I'm going to make is if you write out all the steps and write why you're doing each step without having to look back at anything eventually, and you practice, you know, you're going to have to look back at the rules every once in a while, but pretty soon you get them ingrained so you don't make these mistakes. Okay. Again, all we need to know is the distributive law. This times all this stuff in parentheses is this times this and this times this. Okay, that's a distributive law. And then we add things to both sides. We add a negative 4x to both sides, making sure we do this step so you clearly see what you're doing. And then we simplify, which is pretty straightforward. People are doing that just fine. And move on down. Finally, divide both sides by 2. Okay. Let's do one more. It's a little longer, but the steps are pretty much the same. The rules you use are identical. So just keep your wits about you and do it carefully and write it out the way I'm recommending. That's what I really want to see. To check this problem, you would substitute 7/3 for every x, and you would get 3 times 5 times 7/3. Plus 7 in the same set of parentheses. There are a lot of parentheses here. You got to make sure you maintain the parentheses that are already there. Okay. Plus 2 times 7/3 equals 3 times 7/3 plus 4 times 3 times 7/3 minus 2. A little bunched up there, but that's what it's going to look like. Okay. Now, what are you going to do? Other than beat your head in something hard, try to make the pain of the process go away. Okay. Don't do that. I don't want you to break things, especially your head. Okay. Well, couple of things we can do. It would make a certain amount of sense to do these multiplications inside the parentheses, right? So let's do that. Let's do 3 times 35 thirds plus 7 plus 2 times 7 thirds equals 3 times 7 thirds is just 7. So we escape a fraction right there. Okay. Plus 4 times 7 minus 2. So the right hand side, in this case, all the fractions would disappear. Now with the answers you got, that ain't going to happen. Okay. You're not going to have a 3 here and a 3 here. You're not going to have a 3 here and a 3 here. Okay. Okay, at this stage, made a bad choice with 7 thirds. They got a bunch of 3's in this equation, but we'll live with it. We do 3 times 35 thirds plus 7 plus 14 thirds equals 7 plus 28 minus 2. Now there's a certain amount of simplification we can do. First of all, we can multiply this. We get 105. Well, actually, we get 35 plus 7 plus 14 thirds equals 33. At this stage, we've only got one fraction, okay? Got a denominator of 3. Do we really want to deal with adding that fraction? Do we really want to go there? Probably not. And with your check, you're going to have a denominator on this term and this term and this term and this term, okay? You're going to have 4 denominators in your check. Well, you do the same thing. You've got 4 denominators as you do if you just got 1. I multiply both sides by 3. Well, let's simplify this one more step. 42 plus 14 thirds equals 33. It's not true because it's not really a solution. Okay. We multiply both sides by 3. And that means we write 3, put parentheses around everything on the side and put it in there. Don't just multiply 3 by the first number and forget it. Okay. And 3 times whatever's on this side, which is pretty simple in this case. Well, at this stage, this gives us 3 times 42 3 times 14 thirds equals 3 times 33. Well, 3 times 42 is 126. 3 times 14 thirds is 14. And the right-hand side is 99. Now, the magic is, by multiplying everything by 3, we just got whole numbers here. We don't have any fractions. And this is totally equivalent. This is true if and only if all this is true, assuming I did my steps right, which can be a challenge. Oh, well, this thing doesn't check. Well, you probably know that 7 thirds isn't the right solution. Okay. So what I want you to do is put the right solution in here. And when you get things simplified to a bunch of terms, figure out what you need to multiply by both sides to wipe out all the denominators. Okay, now the correct solution has a denominator of 2. I won't say what the numerator is. I think everybody's got a denominator of 2. I saw earlier a denominator of 7 in one solution because there was one Just one step somebody missed. So I think it should be 2. If you've got 7, go ahead and do it. It's not going to work out. But whatever your denominator is, that's what it's going to be. So when you get down to step like this, where you've got denominators, you'll have 4 of them probably. You just multiply by that denominator, and then they all go away and just got simple numbers that you can deal with. Understand? Okay. That's a real important step because you want to do that when you solve equations too. Okay, so what is f of 2? Then I'll give you a couple of others. Fill in these. If you don't understand one, move on to the next. And we'll fill them in. Now come around and see what you're doing. Okay, everybody did very well with this. Okay. F of 2 is 2 squared plus 1 over 2. All we're doing is x has been replaced by 2, so replace all the x's by 2. Here, f of aardvark. Can't really see it, but it's aardvark squared plus 1 over aardvark, and everybody got that. So I'm not going to write it out real clearly. You want to put parentheses around the word aardvark here, so people don't take this as a product of A's and R's and D's and K's. Okay, you write A squared, R squared, D squared. Okay, if you consider aardvark to be a symbol. Now, if you consider aardvark to be a product of these letters, well, you're still okay because you got parentheses around it, right? So depending on how aardvark is interpreted, you're okay. Well, f of A plus B, should have left myself more room. But actually, I was thinking I'd have to rewrite these over here and explain things. Everybody got them right, okay? With a couple of little glitches. You also need parentheses around A plus B because A plus B replaces X and X is squared. So A plus B, that sum has to be squared. If you write A plus B squared without the parentheses, you have A and then you have B squared. And add them before you square. Okay. F of G, well, that's probably the easiest one once you get into the symbols. G plus 1 over G, right? Now, F of G of X is G of X squared, and I'm pretty sure I saw parentheses around G of X. And that's a good idea. Okay. Now, what if G of X stands for some other function? If G of X equals 2 to the X, then what do you get? F of G of X certainly equals G of X squared plus 1 over G of X, right? What's that equal? If G of X equals 2 to the X. Okay, now at this stage, what you do is really quite simple. g of x equals 2 to the x, right? So any place you see g of x, you can write 2 to the x. Okay? So our situation is if f of x is x squared plus 1 over x, then f g of x is g of x squared plus 1 over g of x. Because x has been replaced by g of x, replace x with g of x, right? Then if g of x equals 2 to the x, then every one of these g of x's can be written 2 to the x. We can replace g of x by 2 to the x. Now, most of you have the problem that you were thinking. Okay? You were thinking about what's that mean, right? You weren't thinking about basically the way you were thinking here. If this equals this, then this can be substituted for this. Just like up here, g of x could have been substituted for x, right? So you got a series of substitutions. Write it out in a little more detail. You replace g of x by 2 to the x. Okay. Now, a little algebra that you should know. I'll write this in a different color. A to the b raised to the c is a to the bc. It's one of your basic laws of exponents. And I think that was something we did in an early assignment. So you should know from those laws that this is 2 to the 2x. And that this is 2 to the negative x. So I don't understand why this could be written this way. Review the laws of exponents. Make sure you do understand because you're going to need them. Okay? Maybe later in the course, in your pre-calculus course. Okay? But you should get that out of the way now. It's something that we assume you know when you start a pre-calculus course. Okay? Of course, the reason you're in here is because, like almost everybody else, you don't know everything. Okay? And that's always the case. Different algebra courses taught by different people emphasize different things in different ways. Right? So there are always things that people don't understand. The rules for exponents are pretty common. Part of that's because they're a little confusing, hard to remember. Okay. All right, well, there it is. Let's do one more. Let's say, let's let I'm just going to give you both functions now. Read that. F of x is 2 to the x, just your toolkit exponential function, okay? G of x is x squared plus 3x. So f of g of x equals what? And then What's g of f of x? Start by just treating g of x like you would a number or a single symbol, and plug it into the f of x function. Okay. And then you just replace that in the second step with what g of x is. Oh, I didn't record any of that. Dang, I'm going to have to do that. So y'all can go. I mean, most of you are staying anyway, but don't go in front of the camera. Okay. Okay, what I just said, and I regrettably didn't have the camera on. F of x is 2 to the x. G of x is x squared plus 3 to the x. This is what we said here. So what is f of g of x? Well, the most obvious thing is g of x has replaced x in the f function. So this is 2 to the g of x. Okay. What about g of f of x? F of x has replaced x in the g of x function. So we're all the x's and we get f of x squared plus 3f of x. Exactly the same thing everybody did correctly down here, but most people overthought it a little bit and tried to do something with it. There's nothing to be done with it at this stage. You're just substituting. Okay, so let's go to f of g of x. It's 2 to the g of x. What can we do with that? Well, we've got g of x equals x squared plus 3x, and we replace g of x with x squared plus 3x. And here we've got a new function that's a combination of the toolkit exponential function, the toolkit squaring function, and a linear function, a multiple of the toolkit linear function. We haven't talked about the toolkit linear function because it's too simple to talk about at this stage. Okay, and that g of f of x is equal to this just by replacing x in the formula for g of x. And f of x is 2 to the x, so we replace f of x by 2 to the x, and replace f of x here by 2 to the x, and there's what we have. Then if we go a step further, the rules of exponents tell us 2 to the x quantity squared is 2 to the 2x. You can't multiply the 3 by the 2 because 2 is raised to the x power. You got to do the exponent before you do the multiplication. So here's what you have. Okay. And again, I said it. It would behoove everybody to look at the last 3 minutes of that video where I just summarized everything you need to know to start composite functions.